This is 4.4 additional equations and inequalities. The first type of equation we're going to start with of these additional ones is radical equations. So radical, that just means we have some type of a root, right, or a fractional exponent. So you're going to do this stuff if you have a radical or a fractional exponent. Okay, so isolate the single radical on one side of the equation or the fractional exponent. Okay, square both sides. If you're doing the fractional exponent, it's reciprocal power. Okay, and then if a radical remains, to repeat steps 1 and 2. Okay, so I'll give you an example, but these are the the 5-step process to check to solve a radical or a fractional exponent equation. But this is very important that you understand this. Okay, step 5 is not a good idea, it is a must. All solutions must be checked in the original equation, and only those that satisfy are your actual answers. But it's not a good idea anymore, it's must be checked. You have to do step 5. Okay. Alright, so let's do an example. Solve the square root of x plus 5 plus 1 equals x. Alright, let's make sure we understand what this is saying. Isolate one of the radicals on one side of the equation. Alright, so that means I want to isolate, there's only one radical here, so I need to isolate it, meaning I need to get this 1 over to the other side. Alright, so we're going to start off with the square root of x plus 5 equaling x minus 1 instead of what the original equation said. Okay, so that's what we mean by isolate the radical. Get the radical part to be the only thing on one side of the equation. Alright, so that's step 1 done. Alright, square both sides of the equation, or the index of the radical. The recip power is what I'm talking about. If it's square root, that's the second power. The cube root, that's the third power, and so on. Alright, the reciprocal power. Alright, this is a square root because there's no index there. That means that it's square. So we're going to square both sides of this thing. So I'm going to take left side squared and right side and square it. Now left side, exactly what we think is going to happen. We get rid of that radical, the square and the radical undo one another, and we just end up with the x plus 5 that's underneath the radical. But on the other side, you've got to remember to FOIL this thing. Okay, it's so tempting for you to think, okay, I just square the x and I square the 1, but that's not how it works. Remember, a square means you multiply something by itself. So we multiply the x minus 1 by itself, and we get x squared. X times negative 1 is negative 1x, and negative 1 times x is another negative 1x. Okay, if you know the shortcut, you know you just combine those and get a negative 2x, and then negative 1 times negative 1 is positive 1. Alright, so we get x plus 5 is equal to this quadratic, which combines to x squared minus 2x plus 1. Alright, now anytime I have a quadratic, I bring everything to one side and set it equal to 0. Alright, try to keep your square term positive. So since it's positive on the right, I'm going to bring the other things from the left side over to the right. Alright, so I end up with 0 equals x squared minus 3x minus 4. Alright, and then I can break that down to x minus 4 x plus 1, alright, factored form, equal to 0. Alright, now set each one of these factored pieces equal to 0. This is continuing this problem up here. I get x minus 4 equals 0, or x equals 4, or x plus 1 equals 0, which means that x would have been negative 1. Now, these are my proposed solutions right now. They're not my solutions, they're my proposed solutions. Okay, all we've done so far in this 5-step process is solve the resulting equations. We haven't done step 5, which must be checked. Okay, so again, take your answers and plug them into the original equation and see if they work. Alright, plugging in 4 into this thing, I get the square root of 4 plus 5 plus 1. Is that equal to 4? Okay, meaning here's my original equation. I'm plugging in 4 in for everywhere I see an x. Okay, so 4 plus 5 plus 1 equals 4. Alright, 4 plus 5 plus 1 equals 4. Alright, 4 plus 5 is 9. So I get the square root of 9 plus 1. Is that equal to 4? Yes, because the square root of 9 is 3, and 3 plus 1 equals 4. So x equals 4 is a solution. Alright, because it does work in the original. Now check the other one. -1. We're plugging in -1 everywhere there was an x. So I get the square root of -1 plus 5 plus 1. Is that equal to -1? -1 plus 5 is 4. Square root of 4 plus 1. Is that equal to -1? Square root of 4 is 3. 3 plus 1 is 4, and 4 is not equal to -1. So what does that mean? That means x equals -1 is not a solution. Okay, so you have to understand that step 5 is a requirement now. We throw this solution out because it doesn't work in the original. Alright, this is called what we call an extraneous solution. The reason why this thing shows up, this -1, is at this step, once we square, from here on, from this moment when we square it on, from this part of the work all the way through, -1 does work. -1 plus 5 is 4. -1 minus 1 is -2. -1 minus 1 is -2, and -2 times -2 is 4. So it works from the time we square on, but it doesn't work in the previous thing, in the original problem. Okay, so that's what we have to check for. Because of the fact we square in our solving process, we bring in the possibility of extraneous roots or extraneous solutions. So you gotta make sure that you do step 5. You have to check. Alright, you must check. It's not a good idea now. It's a part of the process to know if an answer is valid or not. Alright, now if you look at your 5-step process on this next example, you may be scratching your head thinking, how am I going to do it? Because I can't isolate a radical. Well, you can isolate one of them. Right? You don't have to isolate both, but you can isolate one. So we're going to isolate the one that's already isolated. So if there's more than one radical, just separate them, make them on opposite sides of the equation, and just isolate one of them at a time, because that's all you can do. Alright, so let's do like we did before. We've got it isolated, so we're going to square both sides. Alright, now the right hand side's not bad. The right hand side, I just get the 2x minus 5. It's the left side that's ugly. Alright, on this left side, remember you have to multiply this thing times itself. So this square root of 4x minus 8 minus 1 gets multiplied by itself. So we're going to have to do the FOIL method. So this times this. the square root of 4x minus 8 times the square root of 4x minus 8. The square root of anything times that itself is just what's underneath that radical. Alright, so again, this is coming from the fact that this is 4x minus 8 under this radical, 4x minus 8 under this radical. So that's why we're getting the 4x minus 8 outside of the radical. So that's first. Outside, we get a negative times this square root of 4x minus 8. Alright, inside we get another negative times the square root of 4x minus 8. Alright, and then last, negative 1 times negative 1 is positive 1. Alright, and that equals 2x minus 5. Alright, so let's clean up a little bit. We got some like terms here. Alright, this is a like term to this. So we've got a 4x, a negative 8 plus 1 is minus 7, and a minus the square root of 4x minus 8 minus another one is minus 2 square root of 4x minus 8. Alright, and that equals 2x minus 5. Okay, now, in this case, if you look back at your instructions on the first slide, if a radical remains, repeat steps 1 and 2. So isolate a radical, square both sides again. So since a radical remains, we need to try to isolate this radical and then square both sides again. So I'm going to take this 4x and this 7 over to the other side, and I'll have a negative 2 times the square root of 4x minus 8 equals, right, 2 minus negative 4, or 2 minus 4 is negative 2x, and then negative 7 plus, or negative 5 plus 7 is positive 2. Alright, and then I'm going to have to divide. I'm going to divide away this negative 2 only because these are already even. It'll be an easy division to do. Divide away the negative 2. Now notice here, both of these are going to cancel on the right side, okay, because we have a sum up top. We can cancel it because we are factoring out a negative 2 up top, and that leaves us with an x. And a positive 2 divided by negative 2 is a minus 1. Divided by this negative 2 on the bottom, and now those are going to cancel. So we're just left with x minus 1 on the right side now. Alright, so the square root of (4x minus 8) is equal to, only thing left again is x minus 1 because everything else canceled. Alright, and now once we get this other one isolated, we square both sides again. Alright, so you square both sides, you get rid of one radical, and then because the other side is going to have radicals show up again, we square both sides again to get rid of it. Alright, so this radical and that square will take care of one another. Over here we got to full out the x minus 1 again. Alright, we did that on the last problem, so I'm going to go ahead and skip to what it is. It's x squared, alright, minus x times negative 1, and negative 1 times x is negative 2x when we combine them. And then negative 1 times negative 1 is positive 1. Alright, set it equal to 0 just like we did before. So I get 0 equals x squared minus 6x plus 9. Now this particular one, if you factor it, if you try to use the unfoil method, meaning come up with these binomial factors, you're going to get a minus 3 for both terms, or both factors. So that means x equals 3 is the only proposed solution, but we still have to check it. Alright, so we'll come over here to check it in the original. Alright, the original problem, remember, said the square root of 4x minus 8, which we're saying x is 3, minus 1. Is that equal to the square root of 2x, again we're saying x is 3, minus 5. Are these two things equal? So 4 times 3 is 12 minus 8 minus 1. Is that equal to 2 times 3 is 6 minus 5. So 12 minus 8 is the square root of 4 minus 1. Is that equal to the square root of 1? Square root of 4 is 2 minus 1 does equal 1. So x equals 3 is a solution.